Now in this class, let us take strain. So strain means it is giving the change in dimension with the application of force. Whenever we are applying forces on a given body, its dimensions are changing, okay, according to the type of force. Because of it, the change in dimension can measure by using the strain. Okay, let us take in first example. I am taking L length of a body. So L is the initial length. Here what we are doing is, in next one I am applying force, tensile force at both sides. Because of this force, for this, its length is getting increased. Let us take L1 is the final length after application of the forces. So obviously L1 is greater than L. Okay, so here L1 is more than L because of application of forces. Okay, and what is the change in length? L1 minus L. So here I have written change in length is equal to delta L, L1 minus L. Okay, so because of application of force, the change in the dimension is in terms of length del L. Okay, it is L1 minus L. Strain is nothing but it is a ratio of change in dimension to the initial dimension. Okay, how much change is getting because of the application of force to the initial dimension. Okay, here what is the change in dimension? Delta L. Okay, if you are writing strain for this example, okay, change in dimension means length is changing, we can take it is delta L to the initial dimension. What is the initial dimension? L is the initial dimension, so L. So this is the strain in the taken example. Okay, the another example I will take here. Along the x-axis I am taking, let us assume here I am taking along the x-axis. Okay, the force is acting along the x-axis. So here I am taking the force, applied force along the y-axis. Okay, initially I am taking the body is h height. Let us take it is the initial height. I am applying force on it. It is getting more height. Let us take the final height is h1. Okay, so here what is the change in height? Delta h we can take h1 minus h. Okay, and what is the strain in this case? Strain is equal to change in dimension. What is the change in dimension? It is h1 minus h or delta h divided by what is the initial dimension? Initial height is h. Okay, so this is the formula for strain in this case. So here in these two cases, what we have observed means whatever given axis, along that axis how much change in length as well as in height is coming, that value to the initial value. Okay, so here we are not always taking along the x-axis, we are not taking always along the y-axis. We can take any axis, x or y or z axis also we can take. So whatever taken axis, along that how much change in dimension is coming to the initial dimension, this ratio is called strain. Okay, if you are taking the units, this is length and this is length, this is height and this is height, the dimensions are, we are getting 1, it is unit, so it has no dimension. Strain has no dimension, it is the dimensionless quantity. Okay, the symbol we are using for strain is E. Okay, small e, and here we can write E is equal to, it is the strain, change in dimension to the initial dimension. Let us take the types of strain, okay, in a given body with the application of the load. First type is linear strain. As I told, we can take the object either horizontally or vertically, okay, like this. Wherever the force is applying along the axis, if we are taking the object, we have to apply the horizontal force. Okay, we have to take the horizontal axis. If we are taking the object like this means we have to apply the load vertically. If we are taking the object in z axis, we have to apply the load along the z axis. Whatever axis we are taking, along that axis we are taking this strain. Okay, so strain I am taking, we are using the symbol strain E. So it is linear strain, E linear we can write here. It is equal to, so nothing, strain is nothing but change in dimension to the initial dimension. So this is also change in dimension to the initial dimension. But here linear strain we are calling whatever axis we are taking along that axis or along the applied load axis. Okay, we are applying the load along this axis. In these examples also I am taking the applied load is along the x-axis, the applied load is along the y-axis. Okay, so here change in dimension along the application of load along P, okay, applied force to the initial dimension. Okay, so this is the linear strain. Here I want to tell one thing, we are taking three axes. Okay, this is the x-axis, y-axis, z-axis. If you are taking the object along the x-axis, it is the linear, whatever strain we are getting, it is a linear strain along the x-axis. If I am taking the object here, I am applying the force along the y-axis, it is the whatever strain is coming, it is the linear strain along the y-axis. If I am taking the object in z-axis, it is the linear strain along the z-axis. Okay, so whatever axis we are taking, so along that axis how much change in dimension to the initial dimension, this ratio is called linear strain. So by seeing this linear, it is not always along the x-axis, you don't think, along the length only also we can't take. So along the, in this case along the height we are taking. Okay, so linear strain means along the taken axis of the applied load. Okay, applied load axis. So in these three axes, let us assume if we are taking the object here, we are applying the force along the x-axis, means this is the linear axis. Okay, if you are taking the object and applying the force along y, means this is the linear axis. If you are taking, considering z-axis, means it is the linear axis. If you are calling this is the linear axis, means the other two axes are called lateral axis. This and this both are called lateral axis. Okay, so remember it. Take the next one, lateral strain. Okay, so by you seeing this lateral, just now I told you it is the lateral axis, y and z. This is the linear axis in this example. Okay, here I am taking 3D object, means it has 3 dimensions, x, y, z. Okay, I am taking like this. Here this is the x-axis, this is the y-axis, this is the z-axis. Let us assume like that. Here I am applying the force in this direction. Okay, let us take like this. If I am applying the force along the x-axis, let us take P force I am applying. Whatever length is there, it will enlarge. Okay, the length will change. So that strain, whatever strain along the x-axis, it is called, just now I told, linear strain. Okay, and what about other dimensions? Okay, length is increasing. What about this height? Okay, this height and this width. If we are applying the force, this height is getting reduced. Got it? And this width is also getting reduced. Okay, the entire dimensions will change. If you are applying the force along any axis, the other two dimensions also change. Okay, so length is also changing, it is increasing. If you see the height and width, it is getting reduced because of application of this force. Okay, the other two axis dimensions are changing. What are the other two axis names? Lateral axis. Okay, along the y-axis some strain will develop because of change in the height, because of change in the width, strain will develop along the z-axis. That strain is called lateral strain. Okay, so lateral strain, we are using the symbol E, lateral. Here what we are telling, the two dimensions, lateral dimensions are getting reduced. Okay, or we can write down change in dimension, same formula we can write, change in dimension to the initial dimension. Here how many lateral strains are there? Two lateral strains along the y-axis, along the z-axis. These two are the lateral strain. it has one linear strain along the x-axis. From the other two axes it is getting the lateral strain. Okay, here in lateral strain the values are getting reduced. Okay, whatever change in that dimension to the initial dimension. Okay, if you are taking y-axis formula Ey, so y we are taking height delta h by initial height. Okay, similarly Ez along the z axis width we are taking, width is also getting reduced, so delta w divided by initial value w. Okay, these two are the lateral strain if you are taking the 3D object. Okay, if you are taking the 2D body, 2D means only this length and width, it has only one linear strain, one lateral strain, height we are considering. Okay, this one is coming. 2-dimensional means x-axis and y-axis values are coming. If you are taking 3D, one linear strain, two lateral strains will get. Let us take the next one, shear strain. Shear strain will get because of shear force. Let us take, this is the given body, it is fixed at AB, CD are the corners. Let us take. So shear strain will come because of shear force. Shear force we are applying along the surface. So along the surface we are applying. Let us take, we are applying the force like this. Okay, along the surface. Because of it, this object is trying to move like this. Let us take, this will come here, this will come. C is coming to C dash, D is coming to D dash. Okay, because of this force on it, the entire body ABCD is getting the new position AB, C dash, D dash. Okay, so here how to measure the shear strain? Here this is the phi we are taking, this angle. Okay, so this angle will measure the shear strain. We are taking this shear strain in terms of tan phi. Tan phi is equal to, what is the formula here? C dash to the BC. Okay, here. So this is the shear strain. So we are using shear strain symbol gamma, and we can measure the shear strain by using this angle tan phi. Let us take the volumetric strain. So for volumetric strain we are taking the symbol E for strain. Volumetric means VOL we are writing. Here I am taking 3D object. 3D object means 3D body means it has dimensions along x-axis, y-axis, z-axis. Here for volumetric strain, whatever forces we are applying, the volume is changing. Okay, that change in volume to the initial volume, that ratio is called volumetric strain. Okay, if you are applying forces in any direction, the volume is changing along x-axis, along y-axis, along z-axis. That change in volume to the initial volume means before applying the forces, that ratio is volumetric strain. So it is del V by V. Del V means change in volume. For volume we are using this, divided by initial volume V. Or we can find strain along the x-axis, strain along the y-axis, strain along the z-axis will give the total volumetric strain. So these two formulas we can use for finding this strain. These are the important points in today's class. In next class we will see what is the relation between stress and strain, and we will see the Hooke's law. Keep watching.